Hi again, science students. In this video we're going to discuss the link between force and acceleration. Now we make this link using Newton's second law, which says that, in a nutshell, force is equal to mass times acceleration. The definition of this law is actually a bit longer, but just for now this is enough to say that force is equal to mass times acceleration. So this is Newton's second law. So we'll discuss a more formal definition for the law in another video. Now, if force is equal to mass times acceleration, then we can transpose and make A the subject, and acceleration is equal to, what do you think it is? Force over mass. So this is the link between acceleration and force. So we know that if the net force acting is equal to 0, then it follows that acceleration is equal to 0. Because we'll just have 0 over the mass of the object, and 0 divided by anything is 0. I want to show you this animation. So right now this object is a filing cabinet, and our robot mover is going to move it for us. So we're going to apply an unbalanced force. So let's do it. So we push on this, the total force, and the object moves. Okay, I'm going to show the graph of acceleration and velocity. So we know that increasing velocity means we have acceleration. So we can see here that the filing cabinet increased its velocity when we were applying an unbalanced force. And so we can see that the acceleration increased above 0. Now, at this point, as I'm speaking, and for quite some time, since about 4 seconds in, the robot has stopped pushing on the cabinet. Hence, the acceleration is now 0. The object is, or that filing cabinet is sliding off the screen where we can't see it at constant velocity. So the net force acting on it is 0. It's still moving, but it's not accelerating anymore because the net force acting on the object is 0. If I was to turn friction on and do the same thing, so I'll just pause this and clear it, then we know that once we stop pushing, there will be an unbalanced force, friction, acting back on the filing cabinet. So friction's on this time. Let's have a look at these graphs. So I'm going to push, and we have an acceleration, increasing velocity. Okay, I'll let go, and friction brings the object to a stop. So during this time we had deceleration, acceleration went into the negative, velocity decreased because we had friction acting in the opposite direction. Now that the filing cabinet has stopped, the acceleration is 0 because the applied force has returned to 0. The net force acting on the filing cabinet is now 0. So let's apply these understandings to the forces acting on the cars in these pictures. You might want to pause the video and see if you can label these correctly, then I'll have a go at it. Okay, so this first one, we've got the car, and we have a gravitational force acting downwards, Fg. Now the car is not sinking into the road, so equal and opposite to that is a normal force. Now those two forces are still acting when the car is moving in equal and opposite directions. Now we also have a applied force of the engine of the car. I'll just call it F applied. We could call it F engine or something like that. Now clearly when this occurs, friction from the road will be acting in the opposite direction. So I'll put the friction in here. Right. Now those are equal and opposite because right now the car has constant velocity. So acceleration equals 0 because F net is equal to 0. And I should have mentioned that up here as well. Right now F net equals 0, so the car is 0 acceleration. So whether it's the car's at rest or at constant velocity, acceleration is equal to 0 in both cases. So forces are balanced in those situations. But if we look at the situation where a car is accelerating, well, the normal force and the force due to gravity are still equal and opposite. So the car is not accelerating upwards or downwards, okay, but it's accelerating forwards. So that means that the force from the engine, the applied force, is now greater than the force due to friction. So if we were to top to tail those vectors, we can see that the net force is now this one here that I've just drawn in. So F net is now greater than 0, hence the car has acceleration greater than 0 in that forwards direction. So in a nutshell, if the net force acting on an object is greater than 0, then that object will accelerate in the direction that the force is acting. Okay, so now go ahead and try some questions in the description for this video.